Our researchers, our engineers, formed an entirely new group to look into ways of doing additional crash tests, not in the real world, but in the computer environment. This Total Human Model for Safety, or THUMS, describes all the characteristics, the dimensions, the properties of 2 million different points on the human body. And then we subject the database to the forces that come in through a crash event to see if any one of those points exceeds the force load that we know it's designed to accept. I mean, we know how much force it takes to bruise human skin. We know how much force it takes to dislocate a joint or to break a bone. With over 2 million data points for the body, working at computer speed, we can get much more data in much narrower increments of time. To put the 2 million data points in perspective, when we do a real crash test with a real car, a real barrier, and a real dummy, we're only getting a couple of dozen channels of data off that dummy.
Each organ, because of its tissue density, its water content, whether it's a solid organ, whether it's a hollow organ, all of these factors change how our organs respond to trauma.
Instead of 2 data points for an organ like a liver, we've actually got a digital map so we can look for damage to that internal organ. With conventional crash test dummies, there's a relatively small family that makes up that set of dummies. The Human Model for Safety allows us to test a wider range of conditions with a wider range of people. We've developed a human model of a pregnant woman because there's some unique things going on with a pregnant woman in terms of how you can protect for safety. We've developed a model of an elderly person that represents the loss of bone density, the downward shift in the center of gravity that happens to all of us with aging. The Human Model for Safety has already led to our development of whiplash injury lessening seats. These seats help to reduce the potential of soft tissue neck injuries in a rear-end collision, something that's very hard to model in a dummy. As our researchers began to develop this first human model for safety, they realized that what they were creating didn't currently exist in the automotive space, and they realized that they had a responsibility to share.
Cleaning up trauma on the back end shouldn't be our goal. The goal of people working on the cars as well as the trauma surgeons should be an educational and preventative approach.
There's over a dozen other automakers that have licenses and use the system. It's also offered and used by governmental safety organizations in Japan, in Europe, and in the US. We saw an opportunity to learn more, to learn at a faster rate. And we're very much a learning company. We're all about learning as much as we can and using that learning to improve what we're building next, what we're building in the future.
When you pursue industry-leading safety, you don't just engineer breakthroughs in simulation technology. You engineer amazing.